Yes. Hi guys, my name is Salum Khalid. I'm a certified user of Solidworks software and a level of mechanical design associate. Professionally, I got BSc in mechanical engineering. In today's lesson, I want just to create step by step this assembly. I hope at the end of the lesson, all of you will be able to understand different types of math and different commands in a SolidWorks software. Especially at the end of this lesson, you will be able to understand width method, angular method, creating coordinate system on an assembly, locating center of mass of an assembly, and the other normal methods in SolidWorks software. I hope at the end of the lesson you'll be able to understand all those steps. Just be closer to me so that you can be one of the guys who understood the lesson. Thank you. Just start like this. Just go into the file, then new, choose an assembly, then in order to create the assembly like that, you need to have ready-made, ready drawn components of what you want to create assembly. So for my assembly, I got the chain link, I got the long pin, and I got the short pin. Using all those three components, and I'm confident that I'm going to create that component and locate the center of mass of an assembly. So I'm just starting with long pin. Browse the long pin on a screen like that. Then right click on a component and then float. I just want to make it fully defined by mating with different planes. So what I'm going to do is click on an assembly on the menu and then click mate. I just made the front plane of an assembly with the front plane of the long pin and then say OK. Repeating the same, mating the top plane of an assembly with the top plane of the component, coincident, then say OK. And then last one, mate the right plane of an assembly and the right plane of the component constant, and then say OK. Then after that, this component is going to be fully defined. For you to be able to locate the center of mass of an assembly, you need to make it fully defined. So this one is fully defined. It cannot no longer be moved in any way because it is fully defined, as you can see on the screen. I want just to move it, but it can't because it is fully defined in all degree of freedom. So the other step followed is browsing the component, and then I choose the chain link and then I browse the chain link. I just want 4 components of the chain link. So what I'm going to do, just click Control on your keyboard of computer, then hold on a Control and then drag. You can get the first component, then Control, drag, then you get the 4 components. You repeat the same procedure so that you can get even more than 4 components. For me, I just want only 4 components on this assembly so that I can mate them together. So I start mating this one to that hole, mate with that component concentric, and then say okay. That face and that face coincident, then it's okay. I made that hole with that hole concentric, and then I want just this chain link to be at the middle of this chain link. So now what I'm going to do is you go on the drop down menu of the map on the left there, as you can see, you choose the advanced method. On an advanced method, you choose the width method. There are different methods, advanced methods. There's symmetric method, path method, the linear coupler method, and the other methods. But for me, I'm just choosing width method. Then the width method needs 4 faces to be made. So choose the first one, then choose the second face, and then choose the third one, and finally the last face. So the component is just going to be in the middle of other chain link. Then I just twist a little bit like that so that I can be able to make the other chain links. So I made this one with that one. No effect because we are in an advanced method, so we choose the standard method. We just go back to the standard method, then choose concentric method, and it will be like that. But that one is not at the center, so we do the same way as we have done the past component. So we choose the standard method, and after choosing the standard method, we choose the width method. Then the width method like that. The first one, first face, second face, the third face, and the last face, and then choose okay. And we do the last one. We go back to the menu there, and then choose the standard method, and then choose the hole, and then mate with this hole, then concentric. So say okay. I want just to mate in an advanced mate, and choose advanced mate, and then choose the width mate, and then choose that face as normal with this face as normal, and then choose that face as normal and that face. So it is just at the center. After choosing all those, and then say okay. No, just want to choose that one. Twist it a little bit so that the other components can be made nicely. So I just want this guy to mate with the final chain link at the end there. So I just click Control on a keyboard, hold on a Control, and then drag like that. Then you get the other component. Or you can go to the browse to the assembly, then insert the component. You can browse from where you have set your component. Then you make this component with that hole concentric, and then that face with that face coincident, like that. Then say okay. Up to that point, we remained with one component to be made. So in these 3 holes, there's a component is supposed to go in those holes. So go into the assembly, and then insert, then choose the short pin. Say okay. So for me, I want only three components of the short pin. So click on a Control and hold it, and then drag, hold, and then drag. So I just want only three of them. Then using those pins, then I want to start mate them. that component met with this hole concentric, met that one with that face coincident, then say okay. That one with this hole concentric, and that face to that face coincident, then this one with this hole concentric, then met that face with that face coincident, then finally okay. Yes, because I have already made that assembly. The last thing remained is just to create the coordinate system at the top of this long pin, the first long pin. So I want just to create the coordinate system on the top, the center, at the top and the center of the long pin. There. So now what I'm going to do is to mark that origin, which is on top of that long pin, and then go to the menu on top and go to insert and choose the reference geometry, then choose the coordinate system. Coordinate system is going to be on the center and top of the long pin, as you can see there on the screen. So now I choose the x-axis. So on the x-axis I just choose the edge as my reference. Choose the edge as my reference. So because I want this x to go in the right side of an assembly, to go in the same direction in the right side of an assembly, so I'm just going to flip the direction of x. Yes, as you can see. So now the coordinate system is done, and then click OK. So I've already created my coordinate system which I wanted. This coordinate system is going to be a reference when I want to locate my center of mass of an assembly. So up to that point is almost over, but one stage remained to make it more over. So I just put like that. No, put this one like that, and then twist that one in a certain angle like that. So finally my assembly I want to be like that, but this face and this face supposed to be on a 25-degree of an angle, and that face and that face supposed to be in 125-degree of an angle, and that face supposed to be on 130-degree of an angle. So after making those mates, then it will be over, and then the last stage is calculating, evaluating the center of mass of an assembly. So we start the first one. Click on the face and then mate. On a drop down menu, then we choose the angle. No, before choosing the angle, choose the second face there. No, let me repeat. We choose that face and that face. Yes. Then on the drop down menu, we choose angle like that. Then you put 125. No, it's not 125. It's 25. Yes, 125, and then say it like that. And then we just play with these three commands: flip dimension and the meta alignments. So for me, I just untick on the flip dimension, and then click on that one. Yes, it is aligned as the way I wanted. So I say okay. So the first angle has been made, and I want to choose the second angle between two faces. And the first face is that one, and the second face is that one. So I now go to the drop down menu and choose the angle I want. So on the angle, there, I just put 125, then click on that meta alignment, Yes, then it is okay. That's the second one. The last one, I want to make that face and that face in an angle like that. So I just want to choose angular mate like that, and then on the angle there I just put 130, then click on that mate alignment. Yes, like that. That's how I want it to be. Thank you. It's okay. And then click OK again to remove the mate command. Okay, after doing so, I now have the complete assembly of what I wanted. The last stage is evaluating this assembly, locating the center of coordinates, center of mass of the assembly with the reference to the coordinate system we created, coordinate system 1. This coordinate system, you want just to create the location at the center of mass with the reference to the coordinate system 1 we created. So where do we go? We now choose the evaluate menu at the top there, and then choose the mass properties. On the mass properties, there's center of mass, but this center of mass is by default is referred to the default coordinate system of one assembly. For us, we want to choose the coordinate system with reference to the center of mass with reference to the coordinate system 1. Then choose coordinate system 1. Then it goes like this. So these are the center of mass of our component of our assembly. So now we need to compare with the original one. Now the original one is this assembly. All those we have been creating, the coordinate system is this one, and the first angle, second angle, the third angle, like that. So now we want just to see what's the answer of the coordinate system. Thus A is 25, B is 125 degree, and C is 130 degree. So is the center of mass is this one. So we got that answer, and on the list there, the first answer is the right one. So because they match, so this is the first one that is our answer. And because they match, that means we have done the correct assembling. Yes, I hope you understood the lesson on how to make it. You can just practice by your own. What you need to have is having those links, or you can just do by yourself. The only important is to understand different types of mesh. I'm sure up to this point you've already understood things like weight mesh, advanced mesh. You've already understood how to use the angular mesh. You already understood how to create the coordinate system. So such things are very useful in design. And you've already understood different commands in Solidworks. I know they can help you in your long way to go in your design issues. So up to that point, what I can say is thank you, and then welcome back to the following tutorials. I'll just be putting one tutorial after another, so that you can be able to understand different issues of the mechanical design. I hope you enjoyed the lesson. Thank you and goodbye.